As he said, my name is Jeremy Schmeichel. I don't have a handle yet, but I'm sure I'll come up with one hopefully by the end of the evening tonight. So
we call him Schmeichel at work.
Yeah.
So Schmeichel works.
Schmeichel or Gollum. That's kind of the nickname I get at work, so that'll work. Go ahead and bring up my first slide here. Imminent problem on the internet today. IPv4 is running out. We were warned.
Damn those mines.
Service provider challenges. Brian and I are going to be speaking today on who we are, what we do, what is IP version 6, IPv4 versus IP version 6, what are the major differences between the two protocols, why do we need it, and the transition issues that a lot of service providers are going to see, transition strategies, and the future as it stands today. Currently, I'm presently employed at a company called IPv6, which stands for, not irritable bowel syndrome, but Integrated Broadband Services as a network engineer. I've got Cisco certifications. I currently hold an active CCNP in routing and switching. Obviously passed my CCNA before that. I'm working on my CCIE, which is an artist task, and it's an ongoing process.
You just want the jacket.
That's right. It comes with a really cool plaque. I don't know if you've seen the latest plaques. The new CCIE plaques are really awesome. Anyway, I'll let Brian introduce himself.
So this is me. I do DOCSIS. I got a lot of acronyms behind my name. It doesn't mean I know anything. That just means I passed a lot of exams. 17 years in technology. Lots of other cool stuff I like to do. SlimJim100.com and DOCSISHub.com are two sites I maintain.
So, we'll get this started with what is IPv6. Internet Protocol version 6 is the next iteration of the Internet Protocol. Currently today, the vast majority of the Internet is running on IP version 4. There was a version 5 that was developed back in around the late 80s, early 90s, and in 1990 there was an official RFC for IP version 5. Never really formally adopted because IPv4 was already in place and nobody ever dreamed we'd actually run out of IPs. Nobody ever dreamed back then we'd have all the smartphones we have today. Nobody ever dreamed eventually your microwave or your fridge is going to have an IP address.
People's imagination sucked back then, didn't they?
Exactly.
Well, 640 RAM was good enough.
That's right. That's all you need.
Well, we did give Africa a /24.
That's right. So fast forward from 1990 to 1998, that all changed. The Internet Engineering Task Force, or IETF, is the more common acronym that's known by, produced RFC 2460 in response to the impending IPv4 shortage. That's actually still the active IP version 6 RFC. It's evolved greatly over the years. They agreed in this specification that they would only allocate 15% of the initial IPv6 pool until the RFC is revised. And we're about to see that that's a lot of address space. The RFC defined in the initial IPv6 specification. It's greatly evolved over the years. So in IPv6, the address size changed from a 32-bit, just regular binary address, to a 128-bit hexadecimal addressing scheme. Some fun facts. I'm not going to try to say that number, but that's how many IPv6 addresses are available in the new specification versus approximately, I think that's 4,294,967,296 addresses available in IP version 4. Somebody way smarter than me figured out that there's approximately one IP address for every 3 square feet of the Milky Way galaxy in IP version 6. One IP address for every atom on the surface of 100 Earths. Or you could provide the entire IP version 4 range to a device every second for that many years, and it would be the same as the number of addresses in the IPv6 range, roughly.
Basically, we're going to go for a little while once we get there.
Hopefully. But again, obviously nobody ever thought we'd run out of IP version 4 space, so we'll see. So when we get into IPv4 versus IP version 6, this is one of the major differences between the two protocols. You have a much simpler header. A lot of this stuff in IP version 4 isn't ever used. IHL or identification flags, fragment offset, header checksum. None of that stuff is actually ever really used in IP version 4. It's there. But the nice thing about having a simplified header is it actually reduces the processing time per packet. So your routers and your switches that are passing traffic on your networks actually have an easier time running IP version 6 versus getting through all the IPv4 traffic.
Less head, more data.
That's right. The addressing format, just for comparison's sake, right now in IP version 4, everybody knows what a good old private address looks like in binary. IP version 6, that's slightly different, a lot bigger, generally speaking, but anybody who knows hexadecimal and binary, that's generally what it will look like. It's a little...
You've gone from a base 10 where we can understand 192 ... to hex. So you've got to beef up on your basic understanding of hexadecimal. But you'll get used to it and it'll start making more sense.
It's actually funny because I'm thinking about it now. You know, I'm a young kid, still working on my career and getting started on everything. And someday I'm going to be looking back and, you know, in my day, we used to only have 32 bits in our addresses, and the guys were like, "Get out of here! You're crazy." So another major difference between IP version 4 and IP version 6, IPv4 primarily communicates using broadcast messages. So when a host initially comes online, and says, "Hey, I'm here, anybody else there, one to any." In IPv6, broadcasts are removed. There is no more broadcast in IP version 6, which is really nice if you're a network admin and you've ever experienced a broadcast storm take down your entire network. You'll be very happy to know that that's going away in IP version 6. It's being replaced by multicast, targeted advertising, so one-to-many, the introduction of unicast, which is one-to-one, and anycast, which is one-to-closest. Anycast can be very similar to when, like, an IPv6 enabled device comes online. It's going to say, "Hey, what's my gateway? How do I get to where I need to go?" And it'll actually target a specific subset of the IPv6 space that's specified for routers and say, "Okay, so I need to go to you to talk to the rest of the internet." Cool.
It's a much quieter way to come on the network. And in general, it's less chatter in your segment. So remember, a lot of times when we talk about different levels of addressing, you talk about layer 2 to layer 3, it's much quieter overall, so it's just an easier way to do things, and it keeps everything from being overutilized from non-important traffic.
Right. And if you ever have any questions, feel free to just shout them out. I'm blazing through this a little quicker than I thought, so this is going to be too difficult to get through the topics that we have here. Go ahead.
What about NAT as a security feature?
What about NAT as a security feature? We're going to get to that. I do talk about NAT. It's interesting how the protocol has evolved over the years. Anyway, in IPv4, all devices have their own unique IP addresses. In IPv6, most devices will have more than one IP address assigned to themselves. It depends on whether they're communicating on the local network or to the global internet. So in IPv4, 3 types of addresses. You have your link local, which is your auto-assigned 169.254, oh my god, my internet is broken, what do I do? Address. Private space, 10 dots, 172 dots, 192, 168 addressing scheme. And then global, which is almost everything else. Obviously, certain subsets of IPv4 space is reserved for multicast addressing, experimental stuff, IETF stuff that Aaron or the other global internet registries won't hand you. In IPv6, there's only 2 types. There used to be 3 types. I'll get to that in a second. But the link local address, is automatically assigned as an IPv6 host comes online, similar to the 169.254 address, except you can actually talk to other devices on your network with this address. Always begins with FE80 followed by 54 bits of zeros. The last 64 bits is the 48-bit device MAC or hardware address with FFFE squeezed in the middle. Why they picked FFFE, I have no idea. I didn't get that deep into it, but it's there. It's going to look like the text in red there, FE80, colon. One of the rules in IP version 6 is you can skip sets of zeros by using a double colon, but you can only use it once. Then remainder, if the device MAC address was 001 Foxtrot Charlie Alpha 208024, you see the FFFE bolded in the middle of that red text there. And so like IP version 4, there are several reserved IPs in IPv6 as well. At one point in time, this is what I was going to get into, during the development of the official IPv6 RFC, and this wasn't that long ago, I think it was back in 2007, 2008, so I guess 3-4 years ago. There was something known as a unique local address, which is what we know as private space today. It was a separate RFC developed for site local address, which was kind of the same thing. They were just competing RFCs. Both of these have since been removed from the official RFC for IP version 6 because essentially it supports NAT, and one of the reasons we're trying to transition to IP version 6 is to get rid of NAT completely. NAT is currently seen as a hindrance to innovation, aside from all the other issues that go along with NAT. But basically, they're trying to get rid of it in IP version 6, which is part of the difficulty that we're currently having.
NAT was originally a Band-Aid because of lack of addresses. It did have some minor security abilities, but in general, NAT was the early on Band-Aid because, oh crap, we're running out of addresses, what do we do? We're still working on IP version 6. And honestly, IP version 6 has gone through so many changes, it's hard for the vendors to keep up with what they support because the RFCs keep changing. Kind of like when we first started doing the 802.11n, there was draft 2, draft 3. That's kind of how we have to do with, we've had to deal with IP version 6 with the different forums and RFCs is it's evolving quicker than the technology can keep up with. It is, each level in RFC isn't existing long enough for the equipment to catch up to it.
So, let's see, next slide. All right, it's actually really funny, that image there on the corner, I just typed in IP version 6 into Google and that popped up, so I just added the IPv6 stuff because I thought it was
I
appropriate.
think that's India, right?
That's why I picked that picture, actually. Panic button in the top. There's been some fear-mongering going on in the press. You actually see the screenshot on the bottom right-hand corners from Fox News, and they love to fear-monger, everybody knows. So, anyway, currently, we are out of IP version 4 address space. The global IANA, the Internet Assigned Numbers Authority, officially gave out their last /8 on February 3rd, 2011. The American Address Authority, ARIN, American Registry for Internet Numbers, still has about 5 /8s available. And to give you an idea, a /8 is just like 10 and anything in behind it. 11, anything in behind it. So it's just basically an entire range that starts with one number. It's still providing allocations, but it's really hard to get address space right now. The company that we work for, IPvS, we do like third-party engineering and data provisioning services for a variety of cable companies throughout North America, Caribbean, and South America. And so I work in engineering, and one of my jobs is to actually assist companies get address space if necessary. And so we help out with the ARIN application, we help out with all the IP justification forms, all that good stuff. It comes down to right now you absolutely have to be what's called dual homed. Basically have 2 upstream carriers, and they can't be just 2 lanes to AT&T. It has to be like AT&T and Level 3, or 2 separate upstream providers, essentially. You have to have that. You have to have used at least, I think, 80% of your currently available IP address space. And you have to document all of this stuff out and be like, yeah, I really need IP space. And then they might give you space depending on how often you request it, how much you currently have, or they might just tell you to suck it up and do NAT or something.
A couple years back, you could just send the application and you'd be assigned addresses. Now they're asked for justification. They're asked for devices behind addresses. They want to see minimum 60% utilization of whatever class of addresses you're requesting. You're requesting Class C. They want to see 180 devices that you're saying you're going to be using and what will be behind them. So, as a company that we work with, IPvS, we're a service provider. So, it's cable corporations, multiple different flavors of ISPs, dial-up, DSL, fiber to the home cable, and we assist in a lot of these small mom-and-pop operations in their addressing schemes. And ARIN has become a real pain to get addresses from, but they're resorting to going directly to their upstream providers saying, I'm going to break my contract if I don't get a /24. So we're pretty much out of IPv4 addresses. And that's kind of why we're talking today is what's next and how to get there.
That's one of the things that Brian and I actually were on a little task force at work to try to come up with some solutions for our customers, how to kind of ease the pain of the transition to IP version 6. As we'll get into later, it's not something that's going to be cheap for a lot of the service providers out there. Obviously, ARIN is going to be handing out addresses for much longer. They may run out this year. Hard to say. They thought that they were going to run out 5 years ago. Obviously, that didn't happen, but I mean, it's definitely coming pretty quick. The reasons for IP version 6 are myriad. Aside from the general fact we're running out of IP version 4 space, part of the IPv4 shortage was due to poor allocations initially. Asia and Africa when the initial IPv4 space was created and being handed out during the early days of the internet, were initially given a single Class C allocation for the entire continent, which is 254 IPs.
254 usable IP addresses for each continent.
I mean, we're talking like, it blows my mind that they would actually only give out that many IPs. Go ahead.
They actually utilized it all pretty quick, too.
Shocking.
With dial-up.
Exactly. And the thing about it is it's interesting. As a result, most of the rest of the world is ahead of the United States in implementing IP version 6 because they had to. Obviously, they were given more allocations after the initial handouts, but they were some of the first countries to widely implement NAT because they had to, and some of the first countries to really push and implement IP version 6 because they had to. They just could not get any more IP space.
And keep in mind, not every country is democratic, so some of them already wanted to control the flow of information, so they were happy to be in the middle anyway.
You
Question?
kind of count how many corporations in America got /8s?
Well, initially, your biggest technology companies, IBM, Xerox, I mean, they took 20% of the initial IP4 day one. The DoD got a good portion of that. They did give back some of that. So Aaron has gone back and asked for justification of large blocks. But you got to understand, as an engineer, when you were given this huge pool of addresses, you didn't just start symmetrically assigning blocks. You kind of bounced around. You may have issued some at the top, some at the end. It's really hard after you've already utilized and addressed public-facing devices to go back and change those. Because early on, a lot of, let's say, coding in general, you may have had static addresses in your actual code that pointed to devices, and if you change that, you broke it. And 10 years ago, we didn't change addresses that often. We got a static assignment, it was always there. A lot of that's catching up. Go ahead.
Does amateur radio still have a /8?
Amateur radio, I'm not sure if they still have a /8, they did originally.
So just the questions were regarding how many corporations in America were assigned /8s that still have them. Actually, one thing that's interesting, not just corporations, but universities. There are a lot of universities around America that are just sitting on tons of /8s. There's all this free address space. And they're just, we got it. We're not giving it up, sorry. Go somewhere else. Nat, do what you need to do. Sorry. Anyway, IPv6 does have numerous improvements over IP version 4, which it should. It's a new version of the Internet Protocol. Has the more efficient header, as we went over earlier. It's designed to get rid of NAT because it's a hindrance to innovation, and it breaks stuff. I mean, there's a lot of things that NAT has issues with games. I mean, some games don't work on NAT, depending on how your configuration is set up. Potential future features are IPsec everywhere, Internet Protocol security, basically security encrypted within every packet. Feature mobility, you can have an IP address assigned to your device and keep that IP address as you roam. Doesn't matter where you go. You can have the same IP address you're using at home that you have at work. All sorts of really cool stuff that you can do in IP version 6. Transition issues. Who would have thought going from a 32-bit basic address to a 128-bit hexadecimal address would have any problems? Really?
You would have thought it had as many as it does.
Right. Well, and to be honest, that's a fair
Changing one number
statement.
from 32 to 128.
Right. You wouldn't think. But anyway, the internet in general has been slow to adopt IPv6, and there are a great number of websites that do not function on the IPv6 internet. Obviously, the big guys like Google, Facebook, eBay. Actually, no, eBay I don't think is fully IPv6 compliant.
I think they participate in IP6 V-Day, and then they shut it back down.
Yeah.
So they broke.
Yeah. Basically, until like a lot of the service providers and stuff, which we'll get into later, start to adopt IPv6 more widely, I guess.
Most of your Fortune 500 are capable to a basic extent where you'll actually get something. But remember, this isn't just IP addressing. This goes back to the DNS Squad A records. It's not just a simple solution. We don't type IP addresses into our browser. We type names. So there's a lot more moving parts, DNS, names, addresses, port security. There's so much more to it than just changing your address and, like U.S. Postal Office where you just send an address change form. It's a lot more difficult than that. And if you want to make it real basic, it seems like an easy solution, but then when you start adding in all the complications, you get yourself buried pretty quick, pretty deep.
Right. And so the service provider industry has been excessively slow to adopt IP version 6. I want to say the primary reason, in my opinion, is the cost. Just the sheer cost and then the knowledge gap in between, because obviously you're going, again, from a 32-bit address to a 128-bit hexadecimal address. Obviously, in regards to all the DNS issues, we don't type IP addresses. There's no way you're going to type a 128-bit hexadecimal address into your web browser to get around the internet. God forbid you have one keystroke that's wrong, and then you're like, oh my god, I got to type that whole thing again. But anyway, multitude of reasons for this, both on the part of the consumer and of the service provider. As with anything, the general attitude has been, don't fix it if it ain't broke. It's quickly becoming, we've got to fix it before it's all broke. Let's talk about the consumer issues first. The number one hurdle to IP version 6 worldwide adaptation from a consumer perspective is, anybody? Yes? Right track, that's part of it.
So he said routers, that would be like CPE.
Right. So
Wireless companies?
Wireless companies, that could be mobile devices.
Could be. Older wireless devices, probably not.
Well, one thing I'm about with ISPs right now is they want to pay for fixed IP address. Under IPv6, they can't really charge you for that because it's part of the IP structure.
Okay,
correct.
So they want to charge you for a static V4, but you're saying V6, everything's pretty much static. And that's true, because you don't need that no more, because there's enough addresses, every device is unique.
Right.
And so they're reluctant to give you IPv6 grade addresses because they see that as a static allocation that they're not charging you for, and that's part of their pricing model.
I would actually question that they're reluctant to give it to you because of it being static, or more or less it could be compatibilities through their network to you. Or the fact that their help desk isn't able to support you when you're not able to get to certain websites. Remember, everybody in this room today can get an IP version 6 address, and I guarantee you we're going to break something we do every day. Because the internet as a whole is not ready. It's the chicken and the egg thing. Which comes first? And that's kind of where we're going to go in this presentation a little bit further. But basically, if we all had IP version 6 addresses today, we still probably wouldn't be able to do everything we do today with IP version 4. And are you willing to accept that when you pay for a service? The average consumer doesn't know it's not the service provider's fault they can't get to eBay because they're running IP version 6 because there is no IP version 4.
No, they just call their service provider like, fix my internet now!
It's broke, fix it. I don't care, I pay you. That's the response.
Well, I'm willing to be a guinea pig, it's still a
That's good. Call your service provider, let them know. I'm sure they would love to hear that.
Actually, you don't even need your service provider. You can actually go to a third party and get your own IP version 6 address and funnel to it.
Yeah, HE.
Yeah. I mean, there's multiple options out there. If you want to be a guinea pig in V6, you don't have to just go through your service provider. You can tunnel 4 to 6.
Which is something we're going to talk about later. But we'll get to that. So the guy that said routers was really on the right track. I pull up this next image. I'm sure everybody's going to have an idea what I'm talking about. What do you see on that graph?
If you can see it, Windows 7, 31%, XP, 31.5%, Vista, 19%, Mac OS 10, 14%, Linux and other, about maybe 3% total.
And this is a rough estimate of the current OS penetration worldwide. So the biggest problem is that Windows XP does not have IP version 6 support, and it still is one of the widely used OSs today, especially in the business world. A lot of businesses haven't moved on from XP yet. I mean, I worked for a company, before I came back to IPVS, I worked for a company called SAIC, and they do a lot of government contract work. They have not budged from Windows XP yet. It's one of those hurdles where they're like, oh, we have to make all of our systems line up, and we have to make sure it's compatible with all the stuff that we use. That's right.
And there's a lot of policies. I mean, when you're talking about large enterprise network, once you get a standard down and you lock and you get a secure image, it's hard to migrate from that, especially when there's feature sets. And remember, Windows Vista actually really doesn't fully support version 6 either. Windows 7 was the first Microsoft version of OS that truly supported the current RFCs.
Although in XP you can install IPv6 support.
Right. It's not actually a full RFC support. It's just snooping. It's dirty.
And you can install the support, but how many of those large corporations are actually going to go ahead and adopt something like that? That's Band-Aid. It doesn't necessarily work with our tools. That's the biggest thing. In an enterprise world, they want to make sure that it works with their other stuff. So the enterprise world has to catch up too. Another consumer hurdle, if I could speak today, is the hardware in a consumer's household, which ties back into the routers statement that we got earlier. Older consumer home routers, think the general Linksys, Netgear, Belkin routers that you usually see day to day, are not IPv6 compatible. If you have an older router and you haven't updated its firmware since you got it, chances are it probably can't take an IPv6 address.
Try to walk your mom through a firmware upgrader at grandma. It ain't gonna happen. Think of the poor help desk soul that's trying to walk somebody through doing anything simple when it comes to somebody that is not computer literate. When you look at the biggest hurdle, that a third larger is on non-compatible v6 operating system. And then probably most, if not all of them, have routers, home routers and gateways that don't support v6. You see some of the problems, and these are problems that the service providers can't really answer. They can't afford to go buy new computers for everybody. They can't afford to replace every home device, every home router edge device. They can do new, they might be able to do that on new installs, but how long would it take for that attrition to flow through to everybody? Go ahead.
So this is real similar to the transition to HDD from analog.
In a way, it's actually more severe in some ways. And his question was the transition from like analog TV to HD TV. The government was giving out coupons to buy converters and everything else because they were shutting down the spectrum.
The problem is you can't legislate another 6 months.
Well, the problem is the FCC can control U.S. airways space, but the internet is not based in the U.S.
This has already happened. When DOCSIS was upgraded, cable providers just started telling people your old DOCSIS router won't work. You got to buy a new one, and they forced everybody to buy it, regardless of what they previously already had.
Depending on the provider, that was one step to move forward. And just in the ISP terms alone, some of the sexy new ways to go about this is require an intelligent 4 to 6 device in every install. So a modem or bandwidth device that intelligently receives a v6 address will forward along v6 address, but any device behind it will provide v4 NAT to 6 translations. They call them e-routers. It's kind of the new sexy term for the NAT device you used to have. So all your legacy stuff still works. All of your current stuff will work and actually pass right through it. That's kind of like the Band-Aid out there right now, but the problem is the vendors, the hardware vendors, are very limited in their selection and they're expensive. And until we can get a mass purchase bulk agreement of these devices and maybe a new standard to certify them so they're all compatible, we're back to the chicken and the egg again.
And just to get through my last bullet point here, sorry. Some may be compatible with the firmware upgrade. Again, imagine trying to walk your mother, your grandmother through a firmware upgrade. Only a select subset of consumers care about keeping the firmware on their router up to date. You know, people like everybody in this room, or using an open source platform such as DPWRT, which I use at home. I love it. It's awesome. Service provider issues a little more complex and a lot more costly as they deal with the general infrastructure of their services that are provided to the consumer. In the world that we work in, the cable DOCSIS world, from Cisco hardware vendor perspective, you must have a fully DOCSIS 3 compatible chassis in order to support IP version 6. It can cost upwards of $100,000. And you have some of the smaller mom and pop shops, that's like their entire yearly budget.
And that's just a single line card. I mean, most of these devices can carry up to 8 line cards. That's not the processor, the WAN cards, or that's just the actual carrier card to do the DOCSIS relay traffic. So it gets expensive pretty quick. And again, as he was talking about, some of the smaller mom and pops only have 500 customers. They don't even have digital service necessarily. They really ain't got the money to put that in. They don't have that money to make that investment. The government ain't giving them money because they're not rural enough, meaning they don't go 700 miles to provide one dial-up internet customer out in the farmland. So they're kind of caught in the middle because they're not a tier 1 Comcast, Cox, Time Warner. So they don't have that budget. And on the flip side, they're really trying to provide good customer service to their customers, and they're running out of addresses. So what do? And that's kind of where they're stuck right now is, I can't spend $100,000 because I don't have it. I can't get any more IPv4 addresses. This V6 thing's great. You helped me get this allotment, but I can't even get it to my customers because my equipment's not capable of actually transversing that. My core might be. My upstream provider is V6 capable. And even if they got the customer V6 address, how much of the internet would work today? So there's so many different places you could focus on to fix the problem.
Other things that service providers face is a knowledge gap, which again transfers back into what we do. One of my jobs as a network engineer is to be up to date on all the IPv4, IPv6 stuff, and make sure that I understand how to get all the configurations in place to assist the service providers in making hardware recommendations, configuration changes, all that good stuff. The leap from IPv4 to IPv6 addressing is complex and challenging. Again, this comes back into the whole, when I've been in the field for 25, 30 years and I'm training some new young guy in my day. Anyway, updates have been made to all the major routing protocols to be compatible with IPv6. RIP NG, which not a lot of people use RIP from a service provider perspective, but believe it or not, it is used from time to time. OSPF version 3, EIGRP, which is the Cisco proprietary protocol for IPv6, ISIS for IPv6, and MP, multi-protocol, BGP4. Why they didn't make it BGP6, I don't know, but it's all right. BGP, as a lot of people I'm sure in this room know, is the protocol of the internet. So again, this ties back into your upstream provider has to be able to support your IPv6 scheme, all that good stuff. The service provider software must support all the required IPv6 protocols on top of the hardware. The service provider must obtain an IPv6 allocation from ARIN, which actually isn't very difficult right now because they're basically saying, here, please take this, use it, please.
They're giving them away.
Like SMUCON law.
That's right. That's right.
It's like the first days of IP version 4. You just tell them IP version 6, like, sure, here you go.
So, and then the service provider's upstream carrier must be able to handle the v6 advertisements via the MPBGP4. Many technologies available to assist in easing the transition to IP version 6 as we get into the transition strategies. And this is, again, the active project we currently have going on at work is developing plans to assist all of the different size providers, because we have providers that have, you know, less than 100 customers to tens of thousands of customers. It just depends on who you're talking about.
No, just our customers are a broad canvas of different sizes. Some of them are just apartment complexes, MDUs. And not all of our customers, I mean, we keep dropping the term DOCSIS. Not all of our customers are DOCSIS carriers. Some are fiber to the home, DSL, you know, cable modem. The equipment we support is not just Cisco, Harris, Motorola, Terayon, Juniper. Anything you can think of that can be sold or bought in the gray market or through the vendor, we end up supporting in some fashion, good or bad.
That's right. And sometimes we would like to take our sales guys out back and install a meeting because they sold something that we're like, now we have to figure out how to configure this. Great, thanks. Anyway, there are new vendors coming on the street every day that offer newer, cheaper solutions. I know we've got, I can't even think of the vendor off the top of my head. There's some new vendor, what was it? Casa that's coming into the game that has real cheap DOCSIS 3 hardware, IP version 6 compatible, I believe, all that good stuff. I guess we'll see when we get it and we try to play with it, see what happens.
We're going to get a lab unit, we're going to break it and send it back.
That's right.
That's my guess. I mean, they've proven themselves, as a company, they've proven themselves in Asia. But we'll see what they can do in North America.
That's right. Well, and to be honest, Asia is a pretty good stress test market, obviously, because they were one of the leading pioneers for adopting IPv6 widely. Again, technologies to ease the transition to IP version 6, dual stack, where you can run IPv4 and IPv6 in your network at the same time. So your customer-facing network can be running IP version 4, but your provider-facing network, you can translate all those addresses into a v6 style addressing scheme. You can do tunneling, 4 to 6, 6 to 4, and again, NAT.
So, and dual stack doesn't actually save your v4 addresses. It's a transition technology. It allows you to run both at the same time. And a lot of the theory is you'll start at dual stack, you'll do a little bit of tunneling, and then eventually you'll migrate to actually straight 6. But it's kind of like the bridge between the two. And as you're saying, if we come up with strategies for our customers, I think the key term right now is the 4 golden band-aids.
That's correct, yes.
That's
golden band-aids.
4 different possible solutions that could fit any one of our potential clients. One of the 4 will work, but they may not all be the sexiest way. Some require money, some require time.
Some require money and time. It just depends. But again, and a lot of this that I'm going over has to do with all of that. I mean, every customer has different needs. Every customer has different capabilities. There are other strategies available around IP brokering and IPv4 reclamation as customers transition to IPv6 and start handing their old IP version 4 addresses back to Aaron. Aaron can then reissue these back out to other people that haven't quite made it yet. Getting a little deeper into the dual stack. Oh, sorry, question.
Yeah, it seems to me what's kind of missing from the whole picture is a top-down strategy in terms of road mapping when IPv4 goes away completely. And if you at least had a target date for that.
So his question was
you could
a lack of
put
top-down
some
strategy.
monetary focus behind how soon should I jump on this ship.
Well, the problem with that is that's a great solution. And with like the comparison earlier to the analog TV to HDTV, well, that's run by the FCC, which is a U.S.-based organization that controls that. The U.S. doesn't own the internet. We designed it, we created it, but it's a cooperation of multiple networks worldwide. Unless you get the UN in every country that actually recognizes the UN to lead it, you'll get the majority of the countries behind it. But it isn't involving feeding the poor, it isn't involving killing people, or it isn't the top priority until everything breaks and there's real financial repercussions. So it's a great idea if we could have a drop-dead date and push people to it. But this is one of those things, the panic is just starting, and the panic should have happened 5 years ago.
You got to feel pain.
The pain will come.
Go ahead.
So I read a proposal called NAT 444 that proposed that the ISPs do very wide-scale natting for you. Instead of having devices down in everybody's home, that's a lot of hardware for people to buy. And I thought they had the math worked out, and they said we don't even need IPv6. What do you think?
That's true, actually. We can NAT forever if we had to. But again, I saw the pain look on his face. It's painful. It's going to break a lot of stuff. There's going to be a lot of things you can't do because you're natting. So, I mean, the problem is that IPv6 is a necessary solution in my mind, at the very least, just to allow the new technologies that are flourishing, especially in the mobile markets, to continue to flourish. Go ahead.
Yeah, I just wanted to state that the problem with that, or the big problem with that, is that the government can't find them.
Yep.
That's right, and that's another one of the things we were talking about, the golden mandates, is here in America, there are regulations around
Everything.
Everything, really. But from a service provider's perspective, there's something called CALIA. Anybody heard of CALIA?
DMCA.
Yeah, DMCA. I mean,
Copyright Act.
Basically, they have to be able to
If Big Brother
report
can't
who
see-
has what IP address at what time.
If Big Brother cannot see what you're doing, and if the major copyright holders, which control half of everything that happens, can't say you stole their stuff, then you're not allowed to have data.
That's right. So that's the unfortunate reality of America. Canada, not a problem. Ironically enough, we have customers in Canada. That's the only reason I know that. So.
In the Caribbean.
And the Caribbean, and anywhere else outside of the United States, generally speaking. I'm sure Europe probably has some sort of similar regulation.
Yeah, outside the U.S. and Europe, it's pretty much still the Wild West. Until you get a subpoena and your local government actually finally listens because of aid packages they're getting from the U.S. You pretty much can do what you want. But in the U.S., you have many laws you have to compile. You have to comply with all these different laws, and every week Congress is making new ways to control your data. So stay on top of what's going on.
There's some new Copyright Piracy Act that's going through Congress right now, actually, similar to SOPA and PIPA. CISPA? Is that what it's called? CISPA, that's right. And so like you were saying, every week something different. You got to keep an eye out. You never know what's going to come down the pipe. But again, it ties back into why is there no drop-dead date? I mean, outside of Europe and the U.S., there is no real regulation authority. Everybody's just kind of doing their own thing and making it work here and there. So, unfortunately, even the big three, Comcast, Time Warner, Charter, Cox, they've all basically said, okay, we've done all we can to implement IP version 6. Everybody else has got to catch up because we're not doing it anymore.
I think their goal right now is by the end of 2012 to have 1% of their footprint served by IP version 6 compatible. 1%.
They're not even close.
And they're not sure if they're going to make that goal. And you're talking about probably almost half of the U.S. broadband population. They'll be lucky if they can get 1% to IP version 6.
Well, maybe people start making websites and servers that you can only connect to if you use IPv6.
So his comment was maybe make websites and servers that are only available through IP version 6.
They'll exclude a lot of customers.
There is. They do that. There's actually a site that offers adult material only to IP version 6 addresses. It was a way to try to promote people to go to IP version 6. Offhand, I can't remember the address. I just remember it was a Slashdot article that got a lot of hits. I think they provided like 4 hours of HD content and adult material, but you could only access it with a V6 address.
Right.
Hey, Steve, volunteer to host the website for Outer Zone 9 and do that to it.
I
There you
know
go.
if I get any better HTML, I'll probably volunteer to build the website.
So on this point, though, I think a better idea would be, and of course we have no power in the future, would be to get like Google, Facebook, all these people to not just to say, IPv6 from this day on. They could do that.
Yeah, if you had your major providers, Google, Microsoft, Facebook, I don't think MySpace counts anymore.
No.
Twitter.
Nope.
Whatever.
I mean, if you got your major social networks, your major social search engines to have a drop dead date of IP version 6 only support, that would move it forward. The problem is do you push the service providers, do you push the content providers, or do you push the government? Who should own this? And at the end of the day, none of them really can carry the full burden of responsibility. And until there's a task force that is international, it's not going to happen. Go ahead.
Counter proposal: the cell phone company should do it first, because they have a lot more control over what handsets people get than these companies you named have.
Actually, yeah, give it to those idiots.
Not only the handsets that people get, but the updates that they push to said handsets.
Yes.
So I mean that's really good, and actually that's one of the reasons why we're running out of IPv4 space so quickly is the proliferation of mobile devices.
Yeah.
I mean it's crazy.
That kind of pushes you back to the top content providers, Apple and Google. They're pretty much the major service providers for cell phones, the actual hardware.
Well, the major iOS providers, it's different.
So, just quick note on that. As far as Verizon is actually concerned, every single 4G device is actually NATed.
Is enabled for or NATed? Every
NATed.
single 4G
Yeah,
device is NATed on Verizon.
Yeah.
Okay, that's cool. I didn't know that. I don't deal a lot with mobile side of the network, so that's pretty interesting.
I don't do anything on a mobile network that I didn't do at Starbucks. I know with Wi-Fi.
Any other questions before I move on? Moving along. All right, we're doing good. We're doing all right. We can go a little over, right?
We'll try to shoot for time.
Try to shoot for time. All right. Dual stack tunneling allows sites to only run IPv4 addresses. They have a tunnel sourced on an IPv4 space to tunnel into the IPv6 world. It also works in reverse. For some reason, you need to tunnel 6 support. NAT-PT, which is Network Address Translation Protocol Translation. Yes, NAT, the tinkerer of innovation, allows a path to IP version 6. Can allow IPv4 devices to communicate to IPv6 networks and vice versa. It can be done via a software solution, which is like on customers' edge routers and things like that, provided they have enough processing power and memory pool, obviously, or a separate vendor-provided NAT hardware solution, which is just a box dedicated to only doing NAT.
Usually a load balancer of some sort. There's many vendors that offer load balancer solutions. And basically, it's kind of a combination of load balancer and packet inspector. They can do V6 translations in multiple different flavors. They're expensive either way you go.
It's not cheap, but at the end of the day, if you don't have the edge hardware, what's cheaper? Getting a dedicated hardware NAT solution or trying to upgrade the hardware that you have that's already taxed. Tying back into IP brokering, service providers that begin the transition to IPv6 early, such as Comcast, Time Warner, and big guys, can look into reselling their available IPv4 space to smaller ISPs that may not be able to support IP version 6. However, right now they're sitting on all their space and saying, we're not giving it up until the rest of you guys went to IP version 6. Sorry.
And this area here, Aaron keeps going back and forth with on what they actually say is legal, since theoretically they own the addresses. Most of your major service providers are actually business class providers already, and they give out slash assignments to their customers. So in a way, they're a sub-agent of Aaron. So the question is can they reallocate those to other providers? And that's where it gets a little gray in some cases. But overall, IP brokering, there's websites that allow you to actually auction off your space or buy space. And I personally think it should be a free market, but there does have to be some control there. But IP brokering is a solution if you're a small provider that you cannot get space from Aaron. Maybe you can call Comcast and have them give you a couple /24s for a flat rate a month.
IPv4 Reclamation. Like I said earlier, as service providers transition into IPv6 and return the IPv4 space they currently utilize to Aaron, Aaron will have additional space to lease out to other smaller ISPs. not the ideal solution because people should be transferring or you know what I'm saying, to IPv6 now. The end goal of the internet regulation world at this time is to push everyone to an IPv6 environment. So, in summary, the transition to an IPv6 world will be a difficult one, but not impossible by any means. There's still a knowledge gap to assist in the support of transition to IP version 6. There's many technologies that exist to transition to an IP version 6 world. It may still be quite some time before we fully see an IPv6 internet, but it is coming, and it cannot be stopped.
And there's also many, many different possible business opportunities if you're an entrepreneur that wants to study the protocol and ways to make hardware solutions that can do the translations. You could use a single RU box to do straight NAT translations from 6 to 4 and 4 to 6. You could build a homemade product and make money off this. This is a real-world issue that can have many, many different solutions. So if you're young and entrepreneurial and you want to go out there and try to make your own golden mandate for service providers, there's probably people listening if you're cheaper than the major vendors. And some of this equipment that they're selling has more features than necessary. So there's a lot of opportunity both for learning, for growth, and for business purposes to help this transition along. And this is going to have to happen. There's no putting your head in the dirt and hoping it goes away. We're out of addresses. We're going to have to find a way to migrate to the next thing.
Any questions?
Yes, CB.
Why don't we just double NAT everything and just allocate more IP addresses that way?
Because double natting will break half of the things that work today. You'll see every single Xbox 360 user crying if you double nat them.
That's actually please double
That's not exactly a bad thing. Well, it depends on the Xbox 360 user.
Well, most of the ones that I hear on voice chat are just like...
Sound just like that.
It's possible you can end child obesity by doing that.
That's right. Back to back.
So the security NAT provides, NAT does not really provide us real security. It's security through hiding. With a properly implemented IP version 6 protocol, there is security inherently built into the protocol, and you should be fine. But again, you got to make sure you're running the right IRC spec. At this point, I think we're out of time, so you can locate us in the hallways and throughout the evening. We appreciate your time and attention. And again, round us up if you need if you have any questions, why not. Thank you for your time.
Thank you very much.
Scans on I never have scan these.
Not the same way you were on